Lesson 65 is titled Advanced Substitution. Now you've been doing substitution problems like this all the way back in Lesson 17 is when you first started doing them, and then we've had all those uniform motion problems that had similar formats to these where you had rate times time type of formulas. Now several of the lessons you've been doing recently, it's a type of problem that you're used to, it just has a little bit different look to it. So look at this problem here, and we're going to solve for the unknown values. Look, we don't know any of them. We don't know exactly what RA is, what TA is, what RB or TB are. We have all these expressions in terms of variables on both sides of the equal sign. Or we have variables that are factors of each other. So let's just think about what we have here. Look at what I have highlighted there. That RA equals 9RB. We could substitute 9RB in for the RA equation at the top. And then the bottom equation, we could solve that for TA, and we'd have it in terms of TB. And so we'd end up with one equation that was in terms of RB and TB, and then we also have another one in terms of RB and TB, so we might be able to simplify that. So usually what you do on these, whenever you get stuck on a problem like that, you're not sure what to do, substitute back into the problems or the equations that have the most variables in them as factors. So we have that RA and TA, and we want to get rid of those factors like that. And so let's go ahead and do that. RA is equal to 9RB, so substituting into that top equation, we would have 9 times RB. And then we would solve TA plus TB equals 12 for TA, and so that would just be TA equals 12 minus TB. We would substitute that in as TA, and so we'd say parentheses 12 minus TB equals 324. We'd expand out on the left. 9 times 12 would be 108 RB minus 9 RB TB, and that equals 324. Now we still have an equation with two unknowns in it though. But look at what I have highlighted. RB-TB equals 180. So we could substitute that in for RB-TB in the equation that we're creating right now. So let's go ahead and do that. And so we'll have 108 times R sub B is equal to negative 9 times 180. There's no equal sign there, so let me move that out of the way, and then we'll get set equal to 324. And so now let's add 9 times 180 to both sides, or just change the side of it. And so we'll say 9 times 180 plus 324. And so on the right we'll end up with 1944. And then on the left we still have 108 R sub B. But we can solve for that. We just divide both sides by 108. And so RB is equal to 1944 divided by 108. And that's equal to 18. And so RA, we can go back and figure out RA now. RA is equal to 9 times RB. That's third equation there on the left. And so we can say 9 times 18. And so we just do that. 9 times 18 is 162. So RA is 162. And so there's RA and RB. Now we still need to figure out TA and TB. We don't have those yet. We can use one of those top equations to figure that out. Doesn't matter which one we do. Let's use the first one, and we'll substitute RA in, and so we'll have 162 times TA equals 324. And so TA would equal 2. Let's just write it over here with the other ones. And then think about our very bottom equation, TA plus TB equals 12. If TA is 2, then TB must be 10. And so we'll say TB equals 10. And so now we're done. So a problem like that, you just have to look at it and realize you don't know any of the unknown values. You don't know any of their values right off the bat. So you have to solve for 4 unknowns. And just start substituting. If you don't know what else to do, start substituting into the formulas where you have variables that are products of each other or factors of each other, and they form a product. Let's go ahead and do one more of these, similar to the previous one we just did. And so let's just go ahead and start by substituting back into that top equation there, because we have R1 equal to 7R2, so we can replace R1, and then we can replace T1 because we can solve that bottom equation for T1. And so we'll have in the top equation, if we substitute 7R2 in for R1, we'll end up with 7R2, and then T1 will become 5 minus T2. Remember, anytime we have a sum, we put that in parentheses. Set that equal to 105. And so we end up with 7R2 times 5, which is 35R2, and then 7R2 times negative T2, which is negative 7R2T2. And that equals 105. Now we know what R2T2 is, so we can replace the R2T2 in this equation we've made with 350, and we'll have one equation with one unknown. 35 R2 minus 7 times 350, that equals 105. And so now we'll have 35 R2 is equal to minus 7 times 350, or just move it over to the right side, so it'll be positive 7 times 350, and that's 2450 plus 105. That would be 2555. Divide both sides by 35, and we get what R2 is. And so we'll say 2555 divided by 35, that equals 73. So R2 is 73. Now remember, we don't know any of the values of those variables. We just know products and sums of them. R2 is 73. R1 is 7 times R2. So R1 is 7 times 73, and that equals 511. So R1 equals 511. Now let's try to solve for one of the times. Substitute 511 into that top equation, and we would have 511 times T1 equals 105. And so we'll just write that like a fraction. T1 is equal to 105 over 511. And then T2, let's just solve that by substituting into R2 T2. So we'd say 73 T2 is equal to 350. So T2, that's just equal to 350 over 73. 73 is a prime number, so we can't simplify that. And so those are our four answers. Got kind of strange fractions there for the two t values, but that's okay. If you add those two t values together, you should get 5 for an answer. A big part of doing algebra problems correctly is using the information that you've been given to solve a problem. And so if you get stuck on these, just keep looking at the information and thinking about what you can use or what you can do with that information to go ahead and solve for the unknown values. In problems like these, the best step is to first substitute into one of those equations where you have the variables as factors of each other, and just keep substituting in until you come up with a solution, meaning one equation with one unknown that you can solve for. Then once you get that one, you can solve for the rest. Okay, well that's all for lesson 65.